video, I'm going to show you 3 cool science experiments, all having to do with plants. So let's get to it. Our first experiment involves anthocyanins. Anthocyanins. What does that mean? It's the chemical in plants that gives it its color, such as this red cabbage. It's red because of the anthocyanins. Okay, let's get to the first step. Okay, so make sure you have some freshly cut cabbage, and then you're gonna pour some boiling water. Make sure to do this with a parent because the water is boiling. Okay, I poured the water at 100 milliliters, and now we're gonna watch it.
Go.
Now you mix the water with the freshly cut cabbage inside. Let's see what happens. We're gonna set this aside for 5 minutes. Be back. While the cabbage is settling, I'm gonna show you guys the 2 chemicals that we're gonna be using for this experiment. Okay, the first one is citric acid. It's on the lower side of the pH scale, so it's an acid. Yes, it's 7 or lower. Now, this is sodium carbonate. It's on the higher side of the pH scale, which makes it a base. Yeah, it's 7 or higher. Okay, I think it's time to check out the cabbage. Now that the cabbage juice is done, we need to filter out the cabbage chunks. And in order to do that, we're gonna make a little filter. So Ryan, would you like to walk us through that? Sure. Fold it into 4 quarters. Then you peel one side out like this, only one. And then you curve it and you stick it in. It should form sort of a funnel kind of shape. Now to filter out the cabbage chunks, I'm gonna use our little filter to take them out. So let's see how this works. Slowly pour it and watch it drip at the bottom. You don't want to pour it all at once because then you're gonna have a bit of an explosion. So you can see the water dripping. Now that I have my cabbage juice all filtered, I'm gonna use my pipette and put 3 milliliters into each vial. This is how it's done. You squeeze the top and you let it suck. Then I have my mark and I'm gonna make sure it's filled up all the way to the 3 milliliter line. This one's filled up to 3 milliliters. Now I'm gonna do the second. Or would you like to do it, Soraya? Sure. Okay, filled up to the number 3 line. Now I'm gonna take this citric acid and put 5 to 10 drops into this vial. Let's start. With 1, 2, 3, 4, 5. I don't think I need to put any more drops because I can see it pink, but let's see what will happen if I add 2 more drops. It just becomes more pink. So that was cool for the just citric acid. Now my sister is gonna put in sodium carbonate into this vial. Go ahead, 5 to 10 drops. 1, 2, 3, 4, 5. And I'll put 2 more. 1, 2. As you can see, this one is sort of pink and red, while this one is like a navy blue, and this one is a green. Okay, now it's time to move on to the next step. Scientists use litmus paper in everyday life to test the pH of a solution. So I'm gonna show you how it's done. Okay, I'm gonna take this sodium carbonate, which is a base, and fill one section with it. As you can see, it's turning sort of like a purple when I'm pouring it. Okay, and comparing this on the pH scale, which I have right here, this would be probably at 11 or 12. Now, we're gonna try that with the acid. So Soraya, would you like to show how it's done? Let's use another piece of paper. Okay, ready? Now pour the red. Oh wow, it's turning pink. That's fascinating. Let's check it out on the pH scale. This is probably at a pH of 2 or 3. So that's pretty fascinating. I hope you guys learned a lot with this demonstration. So now I'm going to explain the next demonstration. Living organisms have different ways of storing nutritious compounds, such as sugars. Ice cream? No, not quite like ice cream. But I'm going to tell you more, and you'll be able to figure out what kind of sugars. Okay, plants, for example, can weave glucose, a type of sugar, molecules into long chains in a special way. The resulting compound is known as starch, and plants can use it to obtain glucose as needed. Our bodies can also use starch as a source of glucose, which is why starchy foods are very nutritious. For this example, I am going to conduct an experiment using lemons and potatoes. So make sure you already have them equally cut into 4 quarters and filled with boiled water. Now it's time to move on to the next step. Okay, so in order to move on to the next step, you need to let these sit for 5 minutes. So after 5 minutes, I will be right back with you guys. Iodine turns blue when mixed with starch. So in this experiment, we are going to use iodine to determine which of these has starch.
That's going to be interesting.
Yes, it will be very interesting. Okay, so Soraya, do you mind taking 1 spoon of copper sulfate and putting it inside this vial?
Sure.
And be careful. Make sure you guys have your goggles and your gloves while doing this experiment and parent supervision.
Is that enough?
Perfect. Now, slowly and carefully pour it into the vial. Try not to spill anything. Perfect. Now, you're going to take 2 spoons of potassium iodide.
Got it.
Remember, make sure not to spill. Perfect. Now slowly pour it. No rush. Perfect. Now 1 more.
Whoa.
Okay, great. Now, all we have to do is shake it. So I'm going to do that slowly and carefully. Now that this iodine solution is done, and don't worry, I capped it, we are going to put 5 drops using this pipette into each of these. And whichever one turns blue, that one's starch. Okay, let's see what happens. 1, 2, 3, 4, 5. Is this one blue?
No.
Not really. Now let's try the potato. Oops.
1, 2, 3, 4, 5.
Okay, well, that one happened unexpectedly, but now we know that potato solution is made of starch. So that's something really fascinating.
Interesting.
Oh, yes, interesting. And I actually did not expect that. So now I'm going to tell you guys. No, you're putting the. Okay. Okay, guys. Now we're going to move on to the next experiment. Final experiment. We're going to have to make another iodine solution, but don't worry because we already know how to do it. So let's do that and move on to the next step. Now I'm just going to mix this iodine solution for a couple seconds and then move on to the next step. Use this absorbent pad to suck in all of the iodine, or most of it. Then we're going to shake off the crystals because I don't want any of those. So I'm going to do that. This is the easy way. Okay, now we are going to do something pretty cool. Are you ready?
Yes.
For the next step?
Yes.
Let's go.
Okay.
Okay, now my sister is going to take that iodine solution and just color it all over the paper. I don't know why we were exaggerating. It's pretty fascinating. It's sort of like a pastel or something. Doesn't have to be perfect, just get the basics. Now we're going to take our lemon and potato and put it on here, and we're going to wait for 3 to 5 minutes, so we'll be right back. Okay, it's been about 5 minutes, so now let's check out the potato and lemon and see what happened. Okay, let's see. That's really interesting. The potato has the iodine on it. Let's see the lemon. The lemon doesn't. I'm gonna tell you guys the science behind this.
Oh, cool.
Okay, to help you remember that iodine turns blue when mixed with starch, I created a little song. Okay, 3, 2, 1, go. Iodine turns blue when mixed with starch. No, iodine turns blue when mixed with starch. Yes, iodine, 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 iodine turns blue when mixed with starch. In this very video, we took a potato sample. We also took a little lemon sample. We put some iodine in each of them to see which one had starch. And in the end, the potato nonetheless had starch. 'Cause iodine turns blue and mixed with starch. Yes, iodine turns blue and mixed with starch. Yes, iodine, 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 iodine turns blue and mixed with starch.